Our last trigonometric substitution example, again, I think that people would often look at this and say, well, geez, why couldn't I make u equal to x squared minus 3? Remember, we don't want our du to be in the denominator. And because of that, we're going to have to use trigonometric substitution. Now, this is a kind of a different case because I have to do something I don't necessarily like to do, and that's as I'm making my Pythagorean triangle, you'll notice that I can't make x the opposite side. I always like to make x opposite. That doesn't work here because obviously if we're making a Pythagorean triangle, x has to be the hypotenuse. Okay. Now this, x squared minus 3. This is the we're going to use secant. And you kind of need to know that. You need to know this is the one situation where you look and you say, well, I have to use secant. Because you could actually put 3 on either side, the opposite or adjacent side, because, of course, the other side would be the square root of x squared minus 3, and it wouldn't matter. But we do want to use secant. We can avoid using some negatives there. So secant, of course, is the reciprocal of cosine, which deals with the adjacent. So I'm going to put my square root of 3 right here, and then the opposite will be x squared minus 3. Okay, so again, we're making this little Pythagorean triangle. X squared minus the square root of 3 squared is right there. Okay, so again, you kind of got to recognize this one, that secant of theta is equal to hypotenuse over adjacent. So that, of course, means theta is equal to the inverse secant. X is equal to, and dx is that. Let's start rewriting. Okay, so I replaced the x's with square root of 3 secant theta, and I replaced the dx with the square root of 3 secant theta, tangent theta. Well, right away, maybe it's helpful to notice that these will divide to be 1, so they can be gone. We could even go a little further and say, well, secant down here, secant up here, those are gone. That's kind of nice to handle. Up top, let's square it out. So we've got square root 3 secant squared theta minus 3 over 1 now, multiplied by tangent theta. Okay. And we could factor the 3 out. Okay. So we'd have like that. So put the square root of 3 out front. Secant squared minus 1. Oh, I forgot my theta. Okay, secant squared theta minus 1 is tangent theta. So tangent theta multiplied by tangent theta, I've been forgetting my d thetas all the way along, is tangent squared theta d theta. So now we just need to do the antiderivative of tangent squared. Well, using what we learned the other day, we can remember that that is the same as tangent squared is the same as secant squared theta minus 1 d theta. Okay, these are the same. Well, the antiderivative of tangent, or secant squared, is tangent theta. The antiderivative of 1 is just theta. So there, oh, I forgot my square root of 3. Like that. Okay, so antiderivative of secant squared is tangent. Antiderivative of 1 is just theta, and I just multiplied the square root of 3n. Well, now let's replace all the thetas with x stuff. So we got square root of 3 multiplied by, now tangent is, go back to your triangle, it's opposite over adjacent. So we're going to have square root of x squared minus 3 over the square root of 3 plus, or I'm sorry, minus the square root of 3 times theta, which we said was the inverse secant of x over the square root of 3 plus a constant. Now I've kind of run out of room. You know, you'll notice that these two will cancel. This is your final answer right here. Okay, it's the square root of x squared minus 3 minus the square root of 3 inverse secant of x over the square root of 3 plus a constant.